I'm going to help set up 24 and 25 for you. We may not solve them all the way down, but I'll at least help you make sure you get the equation correctly. We have a starting amount of frogs that's increasing at an annual rate. Okay, so that tells us n is 1 of 22%. That's 0.22. And basically we're just using a regular old exponential growth function. You could also think about it as the amount is some starting amount times 1 plus a growth rate or minus a decay rate to the number of times we do that growth or loss. Since we're increasing, we're dealing with a plus sign in our equation. So the amount of frogs is 100 times 1 plus 0.22 to the t. You could do 100 times 1.22 to the t. Yeah. And so then they say, well, when will there be 400 frogs? 400 frogs, we're quadrupling the amount of frogs we have. So you have 4 equals 1.22 to the t. And number 25, we got a deadly strain of bacteria released by a supervillain, created zombies, and the population of zombies doubles every 2 days. Okay, this is a new kind of timing for us. Currently there are 30 zombies. How many days? That's the principal number of zombies. How many days before there is more than 30,000 zombies? Okay. And in my class we watched this video about the coronavirus, and we talked about how you look at 30,000, you're like, wow, 30,000, that's crazy. So far from 30, but when you're talking about doubling, you're talking about multiplying something. Because multiplying 30 by 2, not a huge deal. Multiplying 3,000 by 2, huge deal. One results in, if I multiply 30 by 2, I get to 60. So that's a net change of 30 zombies. But if I had 3,000 zombies, I'm going to still double in 2 days. So in the first example, I gained 30 zombies in 2 days. In the next example, I gained 3,000 zombies in 2 days. It's a very big difference. Okay, that's why exponential growth takes off so sharply. It's when things go viral. But this is bacterial. Okay, anyways, the amount of zombies we have is equal to 30 zombies right now, times what's our growth rate we're doubling, and how often we're doubling every 2 days. So this is the number of 2-day periods. There's another way we could modify this equation a little bit to help us, we get the actual number of days, but I think this is probably the easiest or the best way to go about it. And then we want to know, when are there going to be more than 30,000 zombies? So you divide both sides by 30, and you end up with 1,000 times as many zombies is equal to 2t. So t is equal to log base 2 of 1,000. Right, so how many times do you have to double to get to 1,000? I guess this t is actually the number of doubles. Okay, and then what are we going to have to do with the number of doubles? Well, we double every 2 days, so then we would have to multiply it by 2 to get the number of days. 2 days. So if this is the number of doubles, we have 2 days per double, then we multiply by 2, and we'll get the number of days that we've been doubling. If you play 2048, then you'll have a good chance of seeing that, knowing what that 1,000 should be. So 2 to what power equals 1,000? So our first double gets us to 4. 6, second double, no, not 6. Third double, fourth double, fifth double, sixth double, seventh double. Wow. Eighth double. This is our 9th double. So only about 18 days. Wow. Okay. So I mean, that's crazy. When we talk about exponential growth, we talk about something that's very, very drastic, especially when we're doubling in this case. So only 18 days to go from 30 to 30,000. You're like, oh, it's not a big deal. Now it is a big deal. By the time it's spring break, we'll all be zombies.